this is the beginning and end. So here oval shape is used to represent beginning and end of a flowchart. In this input and as well as output, and it is processing. So accordingly, this rhombus, it takes only one input and it goes in two directions, one for true and one for false. For I equal to 1 to n, means from 1 up to given number n, we have to keep multiplying the number. Dear students, welcome to Computer Science classes. I am Ravi Kumar Kyar, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysore. Students, let us continue our discussion with the chapter Introduction to Problem Solving. The topic flowchart. So, in our previous session, we have discussed about an algorithm. Now, here we will see what is flowchart. Now, a flowchart is a diagrammatic representation of an algorithm is called flowchart. Now, actually, what of algorithm and flowchart? These two are the two tools to design a solution to a problem. So, flowchart is a diagrammatic representation, whereas algorithm is a textual representation. And here, flowchart helpful in understanding the logic of complicated and lengthy problem. See, as it is a diagrammatic representation, by looking at the flowchart, it's easy for us to get the logic or to know the logic very easily, because in algorithm it was a textual representation, but flowchart is diagrammatic, so it conveys more meaning as compared to algorithm. So it is drawn by using different geometrical shapes. So here, as we have seen in the definition, so it is a diagrammatic representation. How do we draw flowchart? By using different geometrical shapes. Now let us see the different shapes used in flowchart. So here, first we say one is oval. So this is oval. It indicates start. As we have seen in algorithm, see, every algorithm and flowchart must start and it has to an end at particular point. So to represent the beginning of flowchart, we use this oval. Oval is a symbol it represents the beginning of a flowchart, and it also used to represent the end of the flowchart. So beginning and end. So this oval shape is used to, it defines the start and end of a flowchart. Next one is parallelogram. So this is a shape, geometrical shape used for input and as well as output. So what is input and output? As to solve any particular problem, we have to input the data and computer process it and we get the result. So to represent input and output operation, we use parallelogram. Next one is process or calculation. So this is rectangle. So we are using rectangle geometrical shape to indicate the processing or calculation. Next, preparation. So this is, we are using one for loop, a type of program construct. We use this preparation, this is a symbol we are using to represent for loop. So for loop we are using for repetition of statements. Next one is rhombus. This is a rhombus and for decision and branching. So to represent a decision or branching statement, we use rhombus. And this is predefined process called subprograms. And this is connector, or this is a circle, nothing but connection or connector. So we are using the circle to connect the flowcharts written on different papers, on different locations. For example, if our flowchart doesn't fit into one page, so we have to continue on some other page or next page. So to continue or to connect the flowcharts written on two different pages, we use connectors. So here we are using circle. It's meant for connecting two different flowcharts. and arrows. These are nothing but control flow. What is control flow? See, we have seen in algorithm step 1, step 2, step 3 and so on till we reach the end of an algorithm. So here step 1, step 2, step 3, it indicates flow of logic or statement to be executed one after the another. Similarly, in flow chart, to represent the flow, control flow or the next statement to be executed, we use these arrows. Here we are using 4 different types of arrows to represent flow of logic or control flow. Okay, by looking at the different shape, now let us write a flow chart for as an example. Now this is the flow chart to interchange the values of two variables. Now we can also see an algorithm for the same here. Algorithm step 1 start input A and B. Here we have to interchange the values of two variables. So we have to enter two numbers. So input A and B, and this is the logic of the program, logic of algorithm. Then we have to find out the result or we have to print the result. This is an end. So this is an algorithm. Now let us see the flow chart. Here what we have seen in start. So here we are using a oval shape, that is to start a flow chart. Next one is input. We have to input the values of two variables A and B. Now this is the logic. Temp equals to A equal to B and B equals to temp. Then after this processing, this is input, process and output. So it's going to print the final interchangeable values of A and B. We have to stop the flow chart here. So this is the beginning and end. So here oval shape is used to represent beginning and end of a flow chart. In this is input and as well as output, and it is processing. Actually, this is the logic here. What is the logic here? For example, I want to interchange the values of variables A and B. So here I'm using one more variable temp. So let us assume that let value of A is 10 and value of B is 20. Now if I want to interchange that, the logic here is temp equals to A. What is the meaning of this? We are assigning value of A to the variable temp. So we are pushing this A up to this position. So this is value 10. Then after this, so here B, A equals to B. Here value of B will be assigned to a variable A. So we are pushing this variable to here, or the value of B to A. So it's going to overwrite on 10. So value of A becomes 20. Now this is also 20. Next one is temp equals to B, means the value of temp or the value stored in the variable temp will be moved to B or assigned to B. So accordingly, so this temp will be moved to this. So 10, this is 10 is going to overwrite on the same variable or same value. It is 10. So at the end of this process, the values of two variables are interchanged. So this is the logic. So this is processing. So this is a flow chart to interchange the values of two variables, given variables A and B. So this is the flow chart. Now let us move on to next example. It is a flow chart to find area and circumference of a circle. Here, same thing here. This algorithm start and input radius. Now we know the formula. Area equal to pi r squared and circumference equal to 2 pi r. Here we supposed to, as per the formula, we supposed to enter the values of radius. So here radius, and this is a constant 3.14. This is the formula. So according to this formula, we supposed to enter the values of radius. Then this is input and this is processing by using formula, and this is output. So at the end, we have to print the value of area and value of circum. So this is an algorithm. Now let us say the flowchart for the same. Here, as usual, algorithm flowchart starts with oval start, and first one is input radius. RAD stands for radius. So input radius, and here we have written radius. So input radius, and here formula area equals pi r squared. We used to write r into r, or radius into radius. This is what the value we have entered for this. Then for circumference, formula is 2 pi r. 2 multiplied by pi, value of pi is 3.14, and multiplied by r radius. So this is calculation or process. Then at the end, we have to print the result, output, area, and circumference of a circle. So this is a flow chart to, and here note down, we have to stop at this stage. So this is the flow chart to find area and circumference of a circle. Now let us move on to one more example. This is to find the greater of two numbers. So first one is start. This is an algorithm. We have to enter the values of A and B. Read A and B. And here we are using if A greater than B. Here we are comparing these two numbers A and B. If A is greater than B, obviously we have to say A is greater or largest. Suppose if condition fails. Else means what? Here else means this is fail. Condition is not true. In that case, we have to print B is largest. And we have to stop. We have to close that, or we have to end this algorithm. So same logic for this here. And here start beginning of flow chart. Input A and B. We have to enter two numbers or values of two numbers A and B. Then here we are using this rhombus. This is a rhombus. It is a decision making diagram or decision making geometrical shape. So here inside this we are going to write the condition. Look at this algorithm. Here this is the condition, A greater than B. This is a condition. Same thing we are writing here. So if you look at this, any condition will be having most probably the two possible answers, either true or false, or yes or no. So accordingly, this rhombus, it takes only one input and it goes in two directions, one for true and one for false. So here A greater than B. So if suppose A is true, or A is greater than B is true, in that way we have to print A is greater. So output A, we are using this flow lines to print output A. So after printing the value or the result output A, we have to stop or we have to close this flow chart here. Suppose in this condition, if condition fails or A greater than B, if it is false, false means obviously B is greater. So we have to print or we have to output B and we have to stop this flow chart here, or we have to end the flow chart here. So this is the flow chart to find greatest of two numbers. And here we have used one more geometrical shape, rhombus, decision making box. And again we have used as usual for input parallelogram and for output parallelogram, and this is oval to start as well as stop flow chart. So this is a flow chart to find greatest of two numbers. Next example is to find factorial of a number. So already we have learned in our algorithm what is factorial. It is multiplication of given number from 1 up to given number, or successive multiplication of the digits from 1 up to the given number n. So same thing here. Here you can compare this as well as this flow chart here. And here input n, we have to enter one number and that is n, and here fact equals to 1. We have to initialize the variable fact equals to 1. This is initialization of variable fact equal to 1. At the beginning, let it be 1. So this is input and this is processing fact equal to 1. And we are using formula here. This is for loop. This is what we have mentioned here. This is for. This is loop or for loop for repetition of certain statements in a program. So here for I equal to 1 to n means from 1 up to given number n, we have to keep multiplying the number. So what we do is, and this has 2, one is yes, this is for loop, and here this is I. First one value is I value of I equal to 1, 1 less than n. For example, if n value is 5, first time I value is 1. 1 is less than or equal to 5, true. So we have to multiply the fact equals to fact into I. So it's going to multiply fact value is 1, 1 into this I1, 1 into 1, 1. So after this, again it comes to this. Now here I value is changes to 2. So it is 2, 2 less than n, it is true. It comes here, then it is fact into 2. Here it was 1 into 2, 2. So this process, so this step is one particular statement is repeated number of times as long as this condition is true. And after completing the statement, at the end of number of repetition, value will be stored in the variable fact. That is nothing but the factorial of a number that has to be printed out. So, and then we have to stop the flow chart here. So, this is a flow chart to find the factorial of a given number. So, this is an algorithm as well as this is a flow chart. So, flow chart is a diagrammatic representation to represent solution to a problem. And here we are using different geometrical shapes as we have seen here, oval, parallelogram, and in the previous example it was a rhombus and everything. So this is nothing but a flow chart. Students, let us continue our discussion in our next session. Thank you very much.